Hi everyone and welcome. In today's video, we're going to take a look at problems involving approximating areas under curves using left, right, and midpoint rectangle approximations. And so let's get started. Let's begin by taking a look at our first example. We're asked to compute the left endpoint approximation, the right endpoint approximation, and the midpoint approximation using 5 rectangles to approximate the area under the graph f of x equals the natural logarithm of x over the closed interval from 1 to 3. The first thing we need to do is take our interval and divide it into 5 equal chunks. To do that, we have to take the length of the interval, which is 3 minus 1, and divide by how many rectangles we want, in this case 5. So this defines our delta x to be 2/5. This is going to be the fixed width of each rectangle. So to find our endpoints, we have to take our starting value, which is 1 here, and then just keep adding multiples of the width, delta x. And I would like to generate every possible endpoint, so I'm going to let I run from 0 all the way to 5. Now we plug in each value of I into this expression and calculate the value to get these set of values. And so these are the values of x0 through x5. What these values will do is partition the interval 1 to 3 into 5 equal chunks. We will use these to compute the left endpoint approximation and the right endpoint approximation. For the midpoint approximation, remember, we need the midpoint of these subintervals. These define subintervals. And to evaluate the midpoint approximation, I need the middle value. So to find the midpoint of each subinterval, just take 1 plus 7/5 divided by 2, you'll get 6/5. To find the midpoint of this subinterval, just take the left endpoint, the right endpoint, add them up, divide by 2, and this is going to give you 8/5. And so these blue numbers are going to help us with the approximation M5. Lastly, just before we do the calculation and add up all the area of the rectangles, let's just review what the difference between right endpoint, midpoint, and left approximation is. So for a given subinterval of width delta x, the left endpoint approximation is going to use the height of the function at the left endpoint. The midpoint approximation is going to use the height of the function at the midpoint of the subinterval, and the right endpoint is going to use the height of the function on the right endpoint of the subinterval. And so our left endpoint approximation will use this rectangle, whereas our midpoint approximation will end up using this rectangle, and then the right endpoint approximation will end up using this rectangle. Great, and so now all we have to do is just crunch the numbers. Remember, the formula for the left approximation was the width multiplied by the sum of all the function values evaluated at the left endpoints. And so as a result, I runs from 0 all the way to n minus 1, so 5 minus 1 is 4. The width of each rectangle is 2/5, and then the left endpoints are going to be these values. So I just need to evaluate the function at these values and add up the results. These are going to be the heights of each rectangle. So that's what I'm doing. Natural log of 1 plus natural log of 7/5 plus natural log of 9/5, and so on and so forth, all the way to the very last height, which is going to be natural log evaluated at 13/5. Now you put all this in your calculator, and the final answer is going to be about 1.06. Similarly, for the right endpoint approximation, we take the width and we multiply by the sum of the function values evaluated at the right endpoints. This time we're going to evaluate the function at these endpoints. So the first number is natural log of 7/5 plus natural log of 9/5, and so on and so forth, all the way up to natural log of 3, which is going to be the height of the last rectangle. Now you put this in your calculator and you get about 1.5. And then lastly, to find the midpoint approximation, we have to take the width of each rectangle and multiply by the sum of function values evaluated at the midpoint of each subinterval. But this is very simple since we computed the midpoints right here. So we just have to take the natural log of the first midpoint plus the natural log of the second midpoint, and so on and so forth. Add up all these heights, multiply by the width, and we get our answer 1.3. So you see there's a lot of notation here, but when it comes to doing the example, we're adding up a bunch of heights. So if you organize your work like this and find all the endpoints beforehand, then it's very straightforward. Then you're just evaluating the function at each endpoint. Depending on which sum you're using, you might use left endpoints, right endpoints, or the midpoint of each subinterval. Great, let's take a look at one more example. Here we have to find the right endpoint approximation, the midpoint approximation, and the left endpoint approximation using three rectangles on the closed interval from 0 to 1.5 for this given function. So this time we don't have an equation, but that's okay. We're just going to draw our own rectangles on this graph and then add up those areas to evaluate these approximations for area under the curve. To get started, we're going to split our given interval into three equal chunks because we want three rectangles. Well, just take the length of the interval, which is just 1.5 minus 0, and divide by the number of rectangles, 3. So that means we're going to have three rectangles, or three subintervals, each of width 1/2. Next, let's compute every endpoint. To do that, we have to take the starting value, which is 0 in this case, plus I times delta x. And delta x was 1/2. Hence, we're just left with I over 2. Now here, I is supposed to run from 0 to 3 to generate every possible endpoint for both left endpoint approximations and right endpoint approximations. So we are going to use these four numbers to help us with the left endpoint approximations and right endpoint approximations. But for the midpoint approximation, we actually need the midpoint of these subintervals. So add these two numbers up, divide by 2, and that would be the midpoint of this subinterval. It's going to be a fourth. For the next subinterval, just add the two numbers up, divide by 2, you're going to get 3/4, and that's going to be the midpoint on this subinterval. And similarly, the midpoint of the last subinterval is 5/4. Since we only have three rectangles, let's visualize L3, R3, and M3, and it should make it super clear what the difference between how we define the heights of the rectangles are. So for L3, we take our first subinterval, and to define the height, we use the left function value. And so that will be our first rectangle. For the second subinterval, the value of the function at the left endpoint is right here, and so that defines the height. There's our second rectangle. For the third subinterval, the value of the function at the left endpoint is this, so that is going to define the height, and there's our rectangle. So we're just going to add up the area of these three rectangles, and that's going to be the value of L3. For R3, we have the same subintervals, but this time we are going to use the value of the function at the right endpoint. So on the subinterval, the value of the right endpoint is this. This is what defines the height. That's the first rectangle. On the second subinterval, the value of the function at the right endpoint is right here. So that defines the height, and that's my second interval. Similarly, on the last subinterval, the function takes on this value at its right endpoint, and so that defines the height, and so that would be the rectangle being used here. Then we just compute the area of each rectangle here, add them up, and that's going to be the value of R3. And lastly, let's take a look at M3. So here is our first subinterval. And what I'm going to do is find the midpoint of the subinterval, which is this value. And then I'm going to find the height of the function at this input. And that defines the height of my rectangle. Similarly, to define the height of the second rectangle, we take the second subinterval, we find its midpoint. Then we evaluate the function at this midpoint to get the height of this rectangle. And lastly, for the third subinterval, we find its midpoint, we evaluate the function at the midpoint, and that defines the height of the third rectangle. Now we compute the area of these rectangles and just add them up, and that's going to be the value of M3. And so the calculations are very simple. I'm using these formulas, but you can solve this problem without using this formula. Just simply find the area of this rectangle, which is going to be the width, which is 1/2, multiplied by the height, which is 5. Then find the area of this rectangle, which is the width is 1/2 and height is 2. Multiply them together. And the area of this rectangle, the width is 1/2 and the height is 1. Multiply them together. And then add up the numbers you get and you'll get 4. But I've just phrased it in terms of the formula, where you just take the width of each rectangle, then multiply it by the sum of function values evaluated at the left endpoints. And that's what is being done here to get 4. For this calculation, just go ahead and look at the picture and find the area of each rectangle and just add them up. You'll get 2.5. Or in terms of the formula I gave you, it's going to be the width of each rectangle multiplied by the sum of function values evaluated at the right endpoints. And so you get 2.5. And similarly for the midpoint approximation, you can just find the area of each rectangle. Each has a width of 1/2, and the height of each rectangle is given by the function value at the midpoint of each subinterval. Just multiply the lengths and the widths, add them up, and you'll get 2.875. Or in terms of the formulas I gave you, it's going to be the width of each rectangle multiplied by the sum of function values which are found by evaluating the function at the midpoint of each subinterval, and that will give you 2.875. Thanks for watching. If you enjoyed this video or found it helpful, I would really appreciate it if you could like the video and subscribe for more content. And if you have any questions or thoughts, feel free to leave a comment down below. I would love to hear from you.